So moving on to dividing rational expressions. To divide one rational expression by another, we first need to multiply the first expression by the reciprocal of the second expression. So starting out, let's say you have A over B divided by C over D. The first thing you guys are going to do is we're going to flip. We're going to keep our first A over B. Our first fraction stays the same. We change our divide to multiplication, and we flip or find the reciprocal of our second expression. So C over D then becomes D over C. Once we get to this point, we're at exactly what we were talking about when we were multiplying rational expressions. From there on out, it's going to be the same steps that we talked about earlier today. So let's look at example 5. In example 5, we want to divide the expression 5x over 3x minus 12, divide it by the rational expression x squared minus 2x all over x squared minus 6x plus 8. So the very first thing we're going to do is we're going to take our first fraction, our first rational expression, and we're going to, I'm not even going to factor it yet. I'm just going to keep it originally as it was. Change divide to multiply, and I'm going to take my numerator and denominator of my second expression, and we're going to find the reciprocal. So we're going to flip it. So x squared minus 6x plus 8 goes on top. X squared minus 2x goes on bottom. From here, now I can take each numerator and denominator and now factor them into their smaller groups and find out what cancels so that we can simplify it to the most simplified answer we can get. So the next step is taking these values, 5x doesn't get any smaller than 5x. 3x minus 12, I can pull a 3 out of both of these terms, so this becomes 3 times x minus 4. Times, up top I have x squared minus 6x plus 8. I need two numbers that when I multiply I get 8, and when I add or subtract them I get 6. That would be 4 and 2. So I would break these up into groups x minus 4, x minus 2, all over. The denominator in this case both has an x involved. If I pull an x out, which is their common number between both of them, I get 1x left over for my first term, minus 2 left over. Because all of these are attached through multiplication, I can cancel where I can on my diagonals. So the x in this corner, this x, my two outside x's can cancel. My x minus 2, top and bottom, can cancel. My x minus 4 on my diagonals could cancel. And I'm left with 5 as my new numerator over 3, which is my new denominator. Moving on to example 6. Very similar to what we did in the previous example with multiplying. The first thing I'm going to do is I'm going to add my second expression and put it over 1 so that they're stacked exactly the same. From here, my first expression is going to stay 6x squared plus 7x minus 3 all over 6x squared. When I'm dividing by my second expression, I know I can flip it to the reciprocal, so I'm timesing it by the 1 now goes on top. And 2x squared plus 3x goes on bottom. Going through and factoring these a little bit more, simplifying them a little bit better. In this case, when I have a term out in front of x squared, I'm going to treat it just like I would that 3. I want numbers that when I multiply here I get 3. So 3 and 1 are my only options. I want numbers leading out that give me 6, which could be 1 and 6, or 3 and 2. But when this is all said and done, I need 7 to be my middle term. So factoring this correctly, I factor this down into two groups, which I got to be 3x minus 1, 2x plus 3. Again, if you don't know how to do that, now's the time to make sure you ask, because this is going to be a big part of the rest of this unit. The denominator 6x squared can't get any smaller than that, so this stays 6x squared in my denominator. Up top, the 1 remains just 1. And in my denominator, I have x's that are part of both of these groups, so I can pull an x out. So I'm left with 2x plus 3 as my groups in my denominator. Cancel where I can on my diagonals. So the 2x plus 3 cancel, and that's pretty much it. The x can no longer cancel. There's nothing else that's left over on my diagonals that can simplify. So now I just attach them and multiply them straight through. So 3x minus 1 times 1 gives me 3x minus 1 is my final answer up top. And then the 6x squared times x gives me 6x cubed in my denominator. And that's my final answer for example 6. Moving on to our last example with multiplying and dividing rational expressions is simplifying terms when you have more than just two things going on at once, okay? But all the same concepts, all the same skills still hold true. So the first thing I'm going to do is I'm going to add 3x minus 5 over 1 to make sure that they're still stacked the same. Because these two expressions are being multiplied, I'm not going to flip any of them, so I'm just going to rewrite them as what their originals were. So this was 3x minus 5 all over 1. But because I'm dividing my my third expression, I'm now going to multiply by the reciprocal of my third, because that's what I'm dividing by. So x plus 5 goes on top, and 9x squared minus 25 goes on bottom. At this point, I can factor as well as, or simplify as best I can. The x on top stays x plus 5 stays its own group on bottom. I can add parentheses around it if it helps me keep those groups a little bit more organized. 3x minus 5 can't simplify any smaller than that, so I keep that over 1. The x plus 5 on my third expression stays on top, but here I have this difference of perfect squares. And if you remember the difference of perfect squares, remind yourself that you take the values that they were before they were squared. So 9 before it was squared was 3. X squared before it was squared was x. And 25 before it was squared was 5. There's no middle term of x, so you know one of them has to be negative and the other one has to be its exact opposite, which is positive. Those two groups, if you FOIL them, you should end up with 9x squared minus 25 all over again. At this point, all you're going to do is you're going to simplify where you can. X plus 5, even though it's two expressions over, you can still cancel on your diagonals. So the x plus 5 cancel out, and the 3x minus 5 also cancels out. So once you get it as far as you possibly can, what's left over just has the placeholder of 1. So x times 1 is just x. 1 times 1 times 3x plus 5 is 3x plus 5. And that's your final answer. The x's don't cancel anymore. That's as simplified as you can go. So at this point, you have two more Now You Tries, numbers 5 and 6, that you can work on before the next time we get in class, or we meet in class. So make sure you have these Now You Tries attempted as best as possible, and hopefully you come with a couple of questions the next time we meet so we can talk a little bit more in depth about these, the multiplying and dividing process.